All right, if you're gearing up for a Kubernetes exam, you know there are a few concepts that always seem to trip people up. Well, today, we're going to tackle 4 of the trickiest ones head on. By the end of this, you'll have the insights you need to ace those questions. So let's just dive right in. So here's the game plan. First up, we're going to unravel how services talk to each other. Then we'll figure out how to automatically scale up when things get crazy. After that, it's all about security. We're building virtual walls between our pods. And to wrap it up, we'll get into some serious sandboxing for top-tier security. Oh, and definitely stick around for the cheat sheet at the end. It's going to pull everything together for you. Okay, let's kick things off with service communication. Picture this. You've got dozens, maybe even hundreds of microservices all chattering away inside your cluster. It's chaos, right? I mean, how do you manage all that? How do you make sure it's secure, that you can see what's happening, and that it's all reliable? Well, that's exactly the problem a service mesh was born to solve. So, put on your exam hat for a second. If you get a question asking you to pick the right tool to manage all that back and forth between your services, what's your answer going to be? Let's take a look at the potential candidates. All right, here are our usual suspects. You've got your service mesh tools, stuff for ingress, monitoring tools, and of course, deployment tools. Now look, they're all super important in the Kubernetes world, for sure. But only one of these groups is really built for one specific job, managing that internal service-to-service chatter. Okay, let's use a little process of elimination here. Helm and Customize? Nope, those are for packaging up your apps and deploying them, not for managing traffic while they're running, so they're out. What about Prometheus and Grafana? Close, but no. They're like the security cameras. They let you see what's happening, but they don't actually control the traffic. And GKE Ingress and Calico? Think of them as the bouncers at the club's main entrance. They manage who gets in from the outside, but they're not managing the conversations happening between all the people inside. That's the job of a service mesh. Which brings us to our answer. Linkerd and Istio. These are the big names in the service mesh game. And the secret sauce behind them? It's this brilliant little concept called a sidecar proxy. Imagine this, a tiny, separate container like Envoy that you attach to your main application container. It sits right there, next to it, and intercepts all the network traffic coming in and out. This thing gives you superpowers. We're talking automatic retries, rock-solid encryption, super detailed metrics. And the best part? You don't have to change a single line of your application code to get it. So here's your big exam tip. Write this one down. If a question starts talking about managing runtime communication and you see keywords like sidecar proxy or traffic management, boom, your brain should light up and immediately go to service mesh. Think Istio, think Linkerd. All right, so our services are all communicating perfectly? Awesome. But what happens when one of those services suddenly goes viral? You get a massive, unexpected flood of traffic. You've got to scale, and you got to do it automatically. And that brings us perfectly to our next big topic, auto-scaling. Now, this is what we call a good problem to have, right? You're running a big online marketplace, your flash sale is a total success, but your servers are absolutely getting crushed. CPU is through the roof, you need more horsepower, and you need it now. The key question is, how do you automatically change the number of application pods to handle that massive load? So in Kubernetes, you've got 3 main types of autoscalers, and it is so important to know the difference. Let's think of it with a traffic analogy. The cluster autoscaler, that's like adding a whole new lane to the highway. The vertical pod autoscaler, that's like taking one car and making it way bigger and more powerful, like swapping a sedan for a monster truck. But what we need here is more cars on the road. And only one of these autoscalers does that. Only one changes the actual number of pod replicas. And that, my friends, is the horizontal pod autoscaler, or HPA for short. This is your absolute go-to for scaling out. It just sits there, watching key metrics like CPU utilization. The second that metric crosses a threshold you've set, bam, it automatically spins up more identical copies, more replicas of your pod to share the workload. It's a beautiful example of how Kubernetes gives you that amazing elasticity. And here's your exam tip for this one. It's really straightforward. If you see a question that's all about changing the number of application pods or the number of replicas based on CPU or some other metric, the answer is the horizontal pod autoscaler, period. Don't let them trick you with options about scaling the nodes or the resources inside a pod. It's all about the number of pods. Okay, we handled the traffic spike, we've scaled out, and now we've got a whole bunch of shiny new pods. Great. But There's a catch, and it's a big one for security. By default, in Kubernetes, any pod can talk to any other pod. It's kind of like living in a house with no internal walls. Not exactly private, and definitely not secure. So it's time we build some virtual walls. This brings us right to a core idea in modern security. You've probably heard of it: zero trust. The idea is simple. We start by assuming nothing is trustworthy. No communication is allowed by default. So the question becomes, how do we actually enforce that? How do we set up a default deny rule where pods are totally isolated unless we explicitly say, hey, you two are allowed to talk? Let's run through our options here. An ingress controller? Nah, that's for traffic coming from outside the cluster. A service? That's about exposing a group of pods, not locking them down. Now, Calico, this is a tricky one. Calico is involved. It absolutely enforces these kinds of rules. And this is the key thing for the exam, Calico is the implementation. It's the enforcer. It's not the actual rulebook itself. The question is asking about the built-in Kubernetes capability you use to write the rules. And that capability, that native Kubernetes rulebook, is the Network Policy API object. It's really a two-part system. Step one, you need a CNI plugin that can actually enforce these policies, like Calico. That's your enforcer. Step two, you define the actual rules, who can talk to whom inside a network policy resource. I love this analogy. Think of the network policy as the law written in the law book, and Calico is the police officer on the street making sure everyone follows it. You need both, but the law is the network policy. So for the exam, this distinction is everything. You have to separate the rule from the enforcer. When a question asks how you control pod-to-pod communication or how you define the rules for it, the answer they're looking for is the Kubernetes API object, network policy. Don't get distracted by the specific CNI tools that implement it. Okay, we've built our virtual walls between pods with network policies. That's great. But what if an attacker manages to break into one of those pods? Now we need another layer of defense. Our final concept is about putting a container in an even stronger box, isolating its processes from the host machine's core, the kernel. This is where we talk about true sandboxing. So, that leads to a pretty direct question you might see. What is gvisor actually used for in a Kubernetes cluster? What's its job? And the answer is that gvisor is a sandboxed container runtime. It provides an extra strong layer of isolation. What's so cool about it is that it acts as a kind of user space kernel. So think of it like a highly trained bodyguard standing between your container and the host machine's actual kernel. Instead of letting the container make requests or system calls directly to the host's brain, gvisor intercepts every single one of them. It inspects them and only lets the safe ones through. This creates this incredibly tough sandbox that makes it way, way harder for an attacker in a container to do any real damage to the host. Here's the exam tip. This is all about keywords. If you see a question that mentions sandboxing, stronger process isolation, or the big one, syscall isolation, a light bulb should go off. You should immediately think of these alternative, security-hardened runtimes like gvisor or Kata containers. It's not your standard tool, it's not for monitoring, it's a sandbox. Whew, okay. We've covered a lot of ground. We've hit on complex networking, automatic scaling, and two different, really important layers of security. Now let's pull it all together. I've got a final cheat sheet for you to really lock this stuff in before you walk into that exam. And here it is, your masterclass cheat sheet. Let's run it down one last time. You see sidecar proxy or traffic management? Think service mesh. You see changing the number of pods? That's your horizontal pod autoscaler. The question is about controlling pod traffic. The answer is the Network Policy API. And finally, if you see syscall isolation or sandboxing, you know we're talking about runtimes like gvisor. Seriously, this slide right here is your key to nailing these 4 tricky areas. Look, we've taken some pretty complex ideas and boiled them down to simple, memorable takeaways. You know the keywords to look for, you've seen the patterns, you've cracked the concepts, so you're ready to apply them, right? The only question left is, what are you going to do with it? Thanks for watching.